Can you imagine an hour without electricity? Even today, towns and villages in rural areas have to go hours or even days without electricity because of simple problems like a branch falling on a power line. These distribution lines travel hundreds of kilometers through forests or hilly areas where it's very difficult to find faults when they occur. But in recent years, a simple product has been solving this problem. That's called the fault passage indicator. Hey everyone, my name is Sahil, and in today's video, we will learn about overhead line fault passage indicators, and by the end of this video, you will clearly understand what a fault passage indicator is, how it functions, and the various features and different types of fault passage indicators that are available in the market. But why should you listen to me? At Axis, we have been manufacturing products used in low and medium voltage distribution lines for the past 30 years. Our products are approved in more than 80 utilities across India, Africa, and the globe. So, what is a fault passage indicator, or commonly called the FPI? Quite simply, this is a device designed to detect and indicate faults in an electrical distribution network. These indicators work by noticing changes in a current flowing through a power line. If there is a fault on the line, like a short circuit, over voltage, under voltage, or over current, it can create a fault in the power line. Due to this, the system will trip, or it can lead to fire in the power system. The FPI detects such faults and sends a signal back to the monitoring system like SCADA to show a fault and its approximate location. It monitors the system all day, every day, helping to eliminate downtime by quickly identifying the fault location. Now let's understand the need for FPIs. Electrical networks, being exposed to the outdoors, face nature's challenges throughout the year. Lightning, heavy rain, dust, and even local wildlife can make these systems prone to developing faults over time. When faults occur, it can impact large numbers of end users, including both households and industrial areas, leading to dissatisfaction and financial losses for the local utility. Without a fault indicator, utilities and operations and maintenance firms rely on a standard practice where several technicians walk or drive the length of the line to pinpoint the fault's location. This task becomes especially challenging with insulated cables, where cables are grouped together, making it difficult for technicians to locate the fault. The difficulty increases even more if the fault happens at night or in densely forested or hilly areas. The development of FPIs has been driven by the need to reduce revenue losses for utilities and lower the operations and maintenance costs associated with fault detection. Installed in overhead lines, these indicators offer utilities a solution to quickly identify the location of a fault through visual or remote signals. Now let's discuss how FPIs work. One fault passage indicator is attached to each phase of the circuit. This setup allows utilities to monitor currents and detect faults in each phase effectively. By installing FPIs at regular intervals along the line, these devices will spot faults by observing the electromagnetic field around the conductor. The distance between the FPI depends on local conditions and financial considerations. They can be as low as a few hundred meters to as high as a few kilometers in distance. When a fault occurs, the conductor's magnetic field spikes due to a surge of high current flowing through the device, which then drops to zero as the circuit breaker trips. The FPI senses this abrupt change and triggers an alert. This fault indicating LED on the FPI starts blinking to indicate the faulty condition at the site when a non-communicable type FPI is used. And when a communicable type FPI is used, a remote signal is sent to the SCADA center in case of a fault. Let's look a little deeper at these two types of FPIs, communicable and non-communicable. First, the non-communicable type of FPI. This type of device signals an alarm directly on site with an ultra bright red LED flashing. It distinguishes between permanent faults, transient faults, and low battery voltage with 3 unique blinking LEDs. Earth faults trigger 2 different light signals, providing clear notifications for various issues. These indicators are ideal for areas where lines are easily accessible and can be quickly inspected via a nearby road. In this case, the process of locating faults relies entirely on visual signals from the indicators. Now let's explore the communicable type of FPI. These not only alarm on site but also transmit data to the SCADA center via a data collection unit over GSM GPS networks. This is what a data collection unit looks like, also called a DCU. Communicable FPIs are effective in all kinds of terrain because it is not dependent only on visual inspection. The operations and maintenance team has a clear indication on the location of the fault and does not need to waste time on finding it. This is a simple question for our viewers. Have you ever worked on operations and maintenance of electrical lines? What has been your experience with finding faults? Please share your stories in the comment section below. We'd love to learn more. In conclusion, these fault passage indicators are helpful in reducing downtime by quickly identifying the fault location. I hope this video has given you a clear indication of FPIs, and please remember that at Axis we have more than 50 engineers who are ready to assist you with your next power line project. And remember, don't forget to like and subscribe to our channel for more videos on lightning protection, grounding systems, and other electrical engineering topics.